Hello there, and welcome to the Sleepy Story World channel. Tonight, we are setting out on a journey that never truly ends. We are exploring migrations, one of the most powerful and far-reaching patterns in the natural world. Across oceans and deserts, over mountains, and beneath the waves, life is constantly on the move. Wings beat through starless skies. Fins slice through dark water. Hooves drum across open plains in rhythms older than memory. Migration is not just travel. It is timing, instinct, endurance, and astonishing precision. It is the pull of distant feeding grounds and the call of a birthplace remembered after years away. It shapes ecosystems, feeds forests and seas, and links continents in ways we are only beginning to understand. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, allow your shoulders to soften. Allow your breathing to slow. And as the day begins to gently fade away, join me as we wander through the natural world together. Let's begin. Every year, billions of animals relocate, and many never stop moving. Some head for breeding grounds, others chase food, and some simply follow the climate they can survive. The scale is hard to picture until you imagine the sky layered with migrating birds, the sea threaded with traveling fish, and the ground alive with hooves and paws. Many of these journeys are not a single dash from one point to another. They are repeating cycles that keep ecosystems running on time. When a pulse of migrants arrives, predators wake up to opportunity. Plants receive seeds and nutrients delivered in surprising ways. Even the soundscape changes because new voices enter the chorus. Migration is not a side story in nature. It is one of the main ways life stays connected across vast distances, season after season. Humpback whales travel farther than most nations are wide. Each season, they spend one part of the year in cold, rich waters where food is dense and plentiful. There, they build energy reserves because long travel demands fuel. Then they set out for warmer breeding areas, where newborn calves can grow without losing heat too fast. Along the way, they do not simply drift. They can hold steady courses for days, and they can adjust to currents that would push smaller swimmers off track. Their bodies carry scars that record a life in motion, from barnacles to old encounters with predators. Their songs can change over time, and those changes can spread across oceans like shared culture. A whale on migration is not just moving through water. It is connecting distant parts of the planet with one powerful, recurring journey. Some butterflies cross continents on wings which are thinner than paper. They cannot power through storms the way a large bird might. Instead, they depend on timing, temperature, and helpful winds that carry them like drifting leaves with direction. The astonishing part is that in some species, the individuals that leave are not the same ones that return. The journey becomes a relay passed along to new generations that continue the route without ever seeing the starting point. Along the way, stopovers matter. A patch of nectar can mean the difference between continuing and failing. These migrations also reveal how delicate the map can be, because a small shift in habitat can break a chain of safe places. When you watch a butterfly rise from a flower, it can feel like a small moment. In reality, it may be part of a continental story. A tiny Arctic tern can circle from pole to pole and back. This bird weighs about as much as a small piece of fruit. Yet it lives in a world measured in hemispheres. It follows summer itself, feeding in bright waters where fish and plankton gather near the surface. When the seasons turn, it does not settle for a mild compromise. It keeps going, crossing oceans with no land in sight, then arriving in polar daylight again. Its route is not a straight line drawn on a map. It bends with winds, weather, and food, like a living thread stitched through the Atlantic. Over a lifetime, this can add up to a distance that feels almost unreal for something so small. It is a reminder that endurance is not always about size. Sometimes it is about design, timing, and relentless purpose. Many migrants navigate by stars, even on cloudy nights. For some birds, the night sky is not just decoration. It is a compass made of patterns. Young birds can learn the rotation of the heavens and use it to orient themselves, which is astonishing when you remember they are doing this while flying. Yet the sky is not always visible. When clouds cover the stars, migrants do not simply give up and hope. Many switch to other cues, and they can blend information in ways that feel almost like decision-making. They may use the sun's position before dusk, then continue with a different internal guide after dark. They also correct for winds that push them sideways, because getting to the right region matters more than holding a perfect line. This flexibility is why migration can work in a world that is rarely ideal. The route survives because the traveler can improvise. Salmon return to their birth rivers, guided by an invisible chemical map. As young fish, they carry the scent signature of their home waters, and that memory can stay with them through years in the open sea. When it is time to breed, they begin to close the distance, moving from salt water toward the mouths of rivers. The closer they get, the more specific the information becomes, until the water itself seems to tell them where to turn. That return is not easy. They must push against currents, leap obstacles, and endure injuries that would stop many animals cold. The journey is so demanding that their bodies change as they shift from ocean life to river life. When they finally arrive, their presence feeds more than the next generation. Their bodies become food for birds and mammals, and their nutrients can end up in forests far from the stream bank. A single return run can nourish an entire landscape. Some creatures migrate straight up and down, not north and south. On mountainsides, seasons can change over a short distance, so the smartest route is sometimes vertical. As snow melts, plants green up at lower elevations first, then that wave of fresh growth climbs uphill. Animals can follow it like a moving buffet, staying in the best conditions without crossing continents. When winter returns, they drop down again, seeking shelter, warmer air, and easier access to food. These journeys can be short in miles, yet dramatic in effect, because altitude rewrites temperature, oxygen, and weather. Vertical migration can also happen underwater, where layers of warmth and cold stack like invisible floors. What looks like one habitat from the outside can be many habitats piled together. Migration is not defined by distance alone. Sometimes the most important change is simply going higher or lower at the right moment. The largest migration on Earth happens daily, deep in the ocean. As daylight fades, countless small animals rise from the dark toward surface waters to feed. It is a nightly ascent by creatures you may never see, including tiny crustaceans and other drifting grazers. At dawn, they sink again, retreating to depths where predators have a harder time spotting them. This is not a minor shuffle. It is a planet-scale movement of living material, repeating every day, almost like breathing. It shapes how energy travels through the sea, because what feeds near the surface gets carried back down into deeper layers. That affects carbon cycling and the way the ocean stores it over time. It also creates a hidden feeding schedule for larger animals that follow the crowds. When you look at the ocean at night, it seems calm.
Below, an enormous commute is underway, precise and relentless.
Migration can shape ecosystems, feeding forests, deserts, and seas on schedule. When travelers arrive, they often bring resources with them, and those resources can land in places that did not produce them. A herd can graze an area quickly, then move on, trimming plants without wiping them out. That opens space for new growth and changes what insects and birds can thrive there. In dry regions, the arrival of seasonal movers can match brief bursts of plant life after rain, turning a harsh place into a temporary banquet. In the sea, moving animals concentrate nutrients through feeding and waste, which can fertilize waters and support blooms that feed even more life. These are not isolated events. They are repeating appointments that other species learn to rely on. That is why migration matters beyond the traveler. It is a moving force that keeps timing, balance, and connection across whole regions, sometimes across whole worlds. Caribou herds can travel farther than many long road trips. On the tundra, distance is not measured in miles, it is measured in timing. Caribou begin moving as seasons tilt, and they do it in groups so large they can look like weather rolling across the land. They travel to reach fresh grazing, safer calving grounds, and cooler places where biting insects are less intense. Along the way, they cross braided rivers, soft bogs, and stretches where there is no shelter at all. Calves keep up within days of being born, and that alone can feel unbelievable. These routes are ancient, but they are not rigid. Herds adjust to snow depth, ice conditions, and the availability of plants, because a wrong turn can mean starvation. When caribou move, they connect distant habitats into one living circuit. Wildebeest migrations can move so much mass, rivers change their chemistry. When a vast herd reaches a river, the crossing becomes a dramatic collision between land and water. Thousands enter, hooves churning sediment into clouds. Mud and plant debris mix into the current, and sudden pulses of waste add nutrients that were not there the day before. Predators wait because this is a rare moment when strong animals can become vulnerable. Crocodiles seize opportunities, and scavengers gather for what follows. Yet the river is not just a stage for danger. It is a moving system that responds to the herd's arrival. Microbes and insects bloom around the new nutrients. Fish shift their feeding, and the effects can ripple downstream. Even the banks can be reshaped as many bodies climb out on the far side. One crossing can look like chaos. In ecological terms, it is a temporary rewrite of the river's balance. Some bats migrate long distances, carrying pollen between distant forests. At dusk, these travelers leave caves and roosts and head into the open air with a mission written into their appetite. Many nectar-feeding bats visit flowers that open at night, and those flowers often depend on them. As bats feed, pollen dusts their faces and fur. Then the bats keep moving, sometimes over huge stretches of landscape, carrying that pollen like a living delivery service. This can connect plant populations that would otherwise be isolated, which matters for genetic diversity and resilience. Along the route, bats must find reliable feeding stops because a missed bloom can mean a hungry night. They also navigate through changing winds and unfamiliar terrain. When you think of pollination, you may picture bees in daylight. In many regions, bats are doing the night shift, and they do it while migrating. Gray whales can travel along coasts for months without eating much. These whales often feed heavily in rich northern waters, and then they begin a long coastal journey toward breeding lagoons farther south. During their travel, feeding can drop sharply. The whales rely on stored energy and careful pacing, which turns the migration into a test of endurance.
Along the coastline, people can sometimes watch them from shore because the route stays near the continental edge. Calves are born in sheltered waters, and then they must travel north with their mothers while still small. That means the return trip includes teaching, protection, and constant movement through a world filled with hazards. This migration has rhythms that coastal ecosystems can recognize because the whales arrive and pass like a slow-moving season. Following their path is like tracing a living thread stitched along the edge of a continent. European eels begin life in the Sargasso Sea, then vanish inland. Their story starts far out in the Atlantic, in a region defined more by currents than by land. From there, eel larvae drift for a long time, changing shape as they travel. When they finally reach coasts, they transform again into small, transparent eels that can enter rivers and estuaries. Then they disappear into freshwater networks, sometimes traveling far upstream and living for years in places that seem worlds away from the open ocean. What makes this feel mysterious is how hidden the journey can be. Eels slip through dark water, under reeds and the long muddy banks, often moving at night. Later, when they are ready to reproduce, they turn back toward the sea and head for that distant Atlantic birthplace. It is a life split between two realms, joined by a route most humans never see. Monarch butterflies migrate in generations, not as a single round trip. One monarch may begin a journey and never live to see its end. Instead, the route is handed forward like a story passed from voice to voice. A spring generation moves north and lays eggs. Their offspring continue, and then another generation continues again. When autumn arrives, a special generation emerges that lives longer and flies south to overwinter. That final leg can span huge distances, and it ends at sites so specific that a small change in habitat can matter. The astonishing part is that the butterflies arriving in winter have never been there before. They still find the right region, and they form dense clusters that ride out the cold. In spring, they begin the relay again. This is not one traveler remembering a path. It is a species keeping a moving tradition alive, one lifespan at a time. In one night, migrating songbirds can pass over your roof unseen. Many of them travel after sunset when the air is cooler and predators are fewer. Up high, their calls are short and simple, and they often happen in a darkness that hides the motion. You might only notice if you step outside and listen closely, because the sky can carry faint notes that sound like tiny check-ins. Below them, cities glow, and that glow can confuse travelers that rely on natural cues.
When clouds or fog reflect the lights upward, the problem can grow. Birds may circle, lose energy, and waste precious hours. On clear nights, many regain their roots and press on because they are following a schedule written into their bodies. The next morning, the world looks still, yet the night may have contained a moving river of life flowing silently above you. Bar-tailed godwits can fly non-stop for days over open ocean. Imagine lifting off from a coastline and choosing a route with no rest stops, no safe fields, and no second chances. These shorebirds do something close to that. Before departure, they build enormous fuel reserves, and their bodies shift into a mode built for endurance. Then they launch into long ocean crossings where there is nowhere to land. The sky becomes their only road, and the sea below offers no refuge. Winds can help or hinder, so timing is everything. A favorable pattern can mean success, and a wrong departure can mean exhaustion over water. Researchers have tracked these flights and found them astonishingly direct, like a drawn line across the Pacific. What makes it feel even wilder is the scale. A bird you could hold in your hands can outlast storms and darkness for days, supported by stored energy and relentless purpose. Snow geese migrations can turn skies white and fields green. When these flocks move, they do not arrive quietly. They arrive as living weather. The air fills with wings, and the sound can build into a roar that seems to come from everywhere at once. At stopover sites, thousands feed together, cropping plants and digging for roots. That feeding can strip a field down quickly, yet it also stirs and fertilizes the soil through droppings and trampling. The result can be a strange kind of reset. When conditions are right, fresh growth follows, and the landscape changes again. Farmers and wildlife managers pay attention because the timing affects crops, wetlands, and the bird's own survival. Predators do too, because a dense gathering offers opportunity. Watching a snow goose migration is like watching a moving tide of life. One day, the sky is empty. Then it is full, and the ground responds. Some dragonflies cross oceans using winds, like living sailboats. A dragonfly is built for agile flight, but crossing wide water still sounds impossible at first. Yet some species do it by partnering with the atmosphere. They climb high, find strong tailwinds, and let those winds carry them long distances while they steer and adjust. It is less like flapping non-stop and more like riding a moving river of air. Along the way, they may stop on islands or coastlines to refuel, feeding on other insects mid-flight when they can. These migrations can span continents and seas, and they can happen in enormous numbers. That matters because dragonflies are predators. They shape insect communities wherever they pass, and they also become food for birds that track the seasonal pulse. A creature you might associate with a pond can be part of an ocean crossing. It is a reminder that the sky has highways we rarely notice. Shorebirds time migrations to shrimp and crab eggs down to days. For these birds, a stopover is not just a break, it is a calculation. They arrive at coastal feeding grounds when the beach is briefly rich with eggs laid by marine creatures. Those eggs are packed with energy, and that energy becomes fuel for the next leg of flight. If the birds arrive too early, the feast has not begun. If they arrive too late, it is gone. So their timing must match the rhythm of tides,
water temperature, and spawning cycles. When it works, you can see birds feeding frantically, gaining weight fast enough to transform their chances of survival. This tight timing also reveals how vulnerable migration can be. If warming shifts the egg season, or if shorelines are disturbed, the birds may miss the window. What looks like a simple beach scene is actually a precision refueling operation synchronized with the sea. Many birds use polarized light, a hidden compass in the sky. Even when the sun is not a bright disk you can point to, the sky still carries direction. Sunlight scatters through the atmosphere in patterns that create polarized bands. And many birds can detect those bands with their eyes. It means the sky holds a kind of map that humans usually miss completely. A bird can use it at sunrise and sunset to calibrate where north and south should be, then carry that orientation forward as the day changes. This is especially useful when landscapes look unfamiliar or when the horizon offers few landmarks. It also explains why the sky itself can be a navigational resource, not just the ground below. For a migrating bird, that hidden compass can turn a wide, confusing world into a place with reliable bearings. Sea turtles can sense Earth's magnetic field like an internal map. A young sea turtle enters the ocean with no parent to follow, yet it can still set off on a purposeful route. Part of the guidance comes from magnetism. Earth's magnetic field varies from place to place, and turtles can detect those differences like a set of coordinates. That ability helps them stay within ocean regions that offer food and safer conditions, even when currents try to sweep them away. Years later, as adults, the same sense can help them approach the right coastline when it is time to nest. It is not a single signal that says, go left or right. It is more like a layered picture that changes as you move. The ocean can look featureless from the surface, but a turtle is traveling through an invisible landscape of magnetic gradients. Navigation becomes something the planet provides all the time, without a single signpost. Some sharks migrate using temperature boundaries, like invisible ocean roads. In the sea, temperature is not just comfort, it is information. Many sharks track the edges where warm and cool water meet, because those boundaries concentrate life. Plankton gathers, smaller fish follow, and predators arrive next. From above, you cannot see these edges clearly, yet in the water, they can feel like a moving wall. A shark can cruise along that line and find reliable hunting, and it can do it for long distances as seasons shift. These thermal boundaries can also guide sharks toward breeding areas or nursery zones where young have better odds. The road itself moves because currents and weather push water masses around, so the shark must keep adjusting, like following a shoreline that drifts. This kind of migration is not about landmarks. It is about sensing the structure of the ocean and staying on the productive seams. Zooplankton rise at dusk and sink at dawn every day. As daylight fades, tiny ocean drifters begin to climb. They rise towards surface waters where microscopic food is plentiful and where feeding can be fast. Yet the surface is dangerous in bright light because predators can see more easily. So at dawn, the same creatures sink back down into deeper, darker layers. This pattern repeats daily with astonishing regularity, like an elevator schedule set by the sun. It is not one species doing it alone. It is a vast crowd that includes many kinds of small animals, each responding to the balance between hunger and risk. That movement also creates a nightly opportunity for hunters that time their own routines to the ascent. The ocean may look still from above, but inside it, life is commuting with the clock. Dusk begins the climb. Dawn begins the descent. The rhythm rarely breaks. This daily ocean commute moves more biomass than any land migration. If you could weigh the travelers involved, you would find a moving mass that dwarfs famous migrations on land. Night after night, huge numbers of small animals rise from depth and then sink again, and the scale adds up across the entire global ocean. What makes it even more astonishing is that most of it happens far from shore, beyond any human view. This movement is not just a curiosity. It helps shuttle energy through the sea. Animals feed near the surface, then carry that material downward when they retreat. And that changes where nutrients and carbon end up over time. It also sets the schedule for midwater predators that follow the crowd because food appears and disappears with the light. On land, you might watch a herd cross a plain. In the ocean, the biggest migration is hidden in darkness, repeating every day as reliably as sunrise. Even tiny jellyfish drift on purpose, riding currents to new feeding grounds. A jellyfish can look like it is simply being pushed around, but many species can control their depth, and that changes everything. Ocean currents often flow in different directions at different layers. So by moving up or down, a jellyfish can choose which current to ride. It becomes a quiet form of steering. That matters because food is patchy. A good feeding zone can appear where nutrients rise, then fade again when conditions change. By riding the right layer, jellyfish can reach these shifting hotspots and stay within water that suits their bodies. This also helps them avoid danger, because some predators hunt mostly near the surface, while others patrol deeper. The result is a kind of migration that does not rely on speed. It relies on using the ocean's conveyor belts. A creature without a brain like ours can still make choices that shape where it goes. Some fish migrate into rivers, then back to the sea to spawn. For these fish, adulthood is tied to salt water, but the next generation begins in fresh currents. Adults approach a coastline and then push inland, trading wide ocean space for narrow channels and strong flow. The river is not just a route, it is a filter. Oxygen levels change, temperatures shift, and obstacles appear. The fish must find the right tributaries and the right gravel or vegetation where eggs can survive. After spawning, many return to the sea, and the young grow in rivers until they are ready to head out. This strategy can protect eggs from some ocean predators, and it can place young in food-rich freshwater habitats. It also links ecosystems that seem separate. What happens upstream can affect the ocean population, and what happens at sea can determine whether enough adults return. The life cycle is a loop drawn across two worlds, connected by a demanding upstream run. Other fish do the opposite, growing in rivers and breeding at sea. Some species begin life inland, feeding and maturing in rivers or lakes for years. Then a switch flips. Their bodies change for salt water, and they begin moving downstream toward the ocean. The journey can involve navigating dams, altered channels, and sudden shifts in water quality. Once at sea, They travel through environments that may be completely new to them. Yet, their breeding depends on reaching the right offshore areas. This pattern can spread risk across habitats. If a river year is difficult, the ocean phase may still succeed, and vice versa. It also means conservation is complicated, because protecting only one part of the route is not enough. A river can look healthy while the ocean breeding grounds fail, or the reverse. These fish remind us that migration is not one standard story. It can be a reversal of expectations, with childhood in freshwater and reproduction far out in saltwater. Many migrations follow green waves of fresh growth across landscapes. Spring does not arrive everywhere at once. It moves like a slow tide of green, starting in lower, warmer places and then spreading across latitudes and elevations. Many herbivores track that wave because young plants are tender and nutrient-rich. By moving with the greening, animals can stay in the best feeding conditions for longer than any single meadow could provide. This can shape their routes with surprising precision. They are not just going north, they are chasing peak freshness. Predators may follow too, because where grazers gather, opportunity gathers. This also means timing matters as much as distance. If the green wave comes early or late, migrants must adjust or risk arriving when plants are already tough and less nourishing. It is a reminder that migration can be a moving appointment with a season, not just a reaction to cold. The landscape is changing, and the travelers are keeping pace. In deserts, rain can trigger migrations that last only a week. A dry landscape can seem lifeless until a storm changes everything. After rain, seeds sprout, insects emerge, and temporary pools appear. And suddenly, food and water are available in places that were bare days before. Some animals respond quickly, moving in from surrounding regions to take advantage of the brief abundance. The journey may be short in distance, yet urgent in timing. A toad might hurry toward a newly formed pool to breed before it evaporates. Insects can explode in number, and birds may arrive to hunt them while the window is open. Then the desert dries again, and the travelers move on or disappear into shelter. This kind of migration is not about predictable seasons. It is about fast opportunity. Rain writes a short-lived invitation on the sand, and for a brief moment, an entire community answers it. Some birds sleep with half their brain, staying alert while resting. That sounds impossible until you picture a long journey with no safe place to fully switch off. In some species, one side of the brain can rest, while the other side stays awake enough to watch, steer, and respond. The open eye on the waking side can keep scanning for danger, while the resting side gets a brief reset. This ability can help during long migrations, especially when stopping could mean landing in the wrong habitat or exposing yourself to predators. It also hints at how flexible sleep can be in the animal world. Sleep is not always an all-or-nothing event. For these birds, it can be divided into smaller pieces that fit the demands of travel. Rest becomes something you carry with you, like a quiet skill used in short moments when the journey will not wait. A few seabirds can nap mid-air, then keep flying. Out over the ocean, there may be nowhere to land for hours or even days, and that changes what rest has to look like. Some seabirds can slip into brief episodes of sleep while still in flight, using patterns of soaring that demand less constant control. The bird does not simply drop out of the sky, it keeps moving, supported by air currents and practiced stability, as if the wind is doing part of the work. These naps are short, and they are not a substitute for deeper rest forever. Still, they can take the edge off fatigue when the nearest rock or beach is far away. It is a reminder that flight is not always frantic flapping. Sometimes it is gliding, adjusting, and letting physics help. The idea of sleeping while flying sounds like a myth. In the right conditions, it becomes one more tool for survival. Migrating geese save energy by drafting. Like cyclists in a line, when a goose flies, its wings push air downward and outward, and that creates a wake. Another goose can position itself to take advantage of that moving air, reducing the effort needed to stay aloft. Over a long migration, those small savings matter. They can mean arriving with enough energy to survive a cold snap, or to keep going when a storm delays the route. You can sometimes see the flock adjust its spacing with remarkable care, because the best position is not simply close. It has to be placed where the air is most helpful. This is not just teamwork for the sake of togetherness. It is a practical strategy that turns a group into a moving machine. The flock becomes more than many individuals. It becomes a shared engine that carries everyone farther. V-shaped formations can shift constantly, sharing the hardest position. The front of a formation is the most expensive place to fly. The leader meets undisturbed air first, and everyone behind benefits from the airflow that follows. That is why the shape is not fixed like a diagram in a book. It is a living arrangement that changes as birds tire and recover. A bird will slide back when it needs relief, and another will move forward to take a turn. This rotation spreads the cost of leadership across the group. It also keeps the formation stable, because a tired leader would weaken the whole pattern. Watching a flock from the ground, you might think the shape is simple. Up close, it is a constant negotiation of distance, timing, and trust. The formation is not just a symbol of migration. It is a method for making long-distance flight possible, one shared decision at a time. Many migrants fly at night to avoid predators and heat. Night changes the rules of the sky. The air can be cooler and calmer, and overheating becomes less of a threat during long, strenuous flight. Many daytime predators are also less active after dark, which can make the journey safer. Darkness adds its own challenges, yet for many migrants, the benefits outweigh the risk. Night travel also frees daylight for feeding and recovery, and that can be the difference between success and failure during a long season. If you have ever stepped outside after sunset and felt the world settle, it is strange to realize the sky may be busier than it looks. Some nights carry a quiet stream of movement overhead, with travelers passing above cities, fields, and forests. Their timing is not random. It is shaped by survival math. Cooler air, fewer hunters, and a chance to refuel when morning comes. Some insects climb high into the sky to catch fast winds. An insect does not need strong muscles to travel far if it can borrow the speed of the atmosphere. Some species rise hundreds of meters or more, reaching layers of air where winds move like rivers. Once there, they can be carried across regions that would take countless wing beats at ground level. This is not aimless drifting. The choice of when to lift off can match seasonal wind patterns, and the timing can steer insects toward breeding areas or fresh food. From the ground, you might see only a few specks. Above, whole clouds of small travelers can be on the move. This strategy also explains how insects can appear suddenly in places that seemed out of reach. The sky is not empty space. It is a layered landscape with highways at different heights. By climbing into the right lane, an insect turns a local flight into a long-distance migration. Migrants often carry fat reserves that double their body weight. Long travel demands fuel that can be carried efficiently, and fat is a powerful energy store. Before departure, many migrants enter a period of intense feeding, packing away reserves like a traveler filling a backpack with supplies. The transformation can be dramatic. A bird that looked lean and light can become visibly fuller because it is preparing for a stretch where food is uncertain or absent. Those reserves are not just extra calories. They are insurance against headwinds, storms, and missed stopovers. They can also help a migrant arrive ready to breed or defend territory, rather than arriving depleted and late. The idea can feel counterintuitive because we often associate being light with being fast. In migration, being prepared can matter more. The goal is not a sprint, it is a passage. Carrying stored energy can turn a risky crossing into a survivable one, even when the journey lasts far longer than expected. Before departure, some birds shrink their digestive organs to lighten the load. Food processing equipment is useful when you are feeding, but it is heavy, and it consumes energy even when you are not eating. Some migrating birds temporarily reduce parts of the digestive system before long flights, because carrying that tissue is costly when the next meal is far away. The body reallocates resources toward flight, favoring muscle and endurance over gut capacity. It is a striking example of flexibility. The bird is not locked into one design. It can remodel itself for a specific phase of life. This shift also changes what the bird can do right before departure. It must fill up while the system is still ready for heavy feeding. Then, it switches into travel mode, relying on stored fuel rather than fresh meals. Migration is often described as movement across maps. Inside the traveler, there is movement too. Organs change size, priorities change, and the body becomes a different kind of machine for a while. After arrival, those organs grow back in days. Once a migrant reaches a place with food and safety, the rules flip again. Now, the urgent need is not to stay light. The urgent need is to eat, recover, and rebuild. In some birds, the digestive system can expand again quickly, restoring the ability to process large meals. That rapid regrowth helps turn a hungry arrival into a stable recovery. It also supports the next tasks, whether that means preparing for breeding, molting, or building strength for the return journey. The speed is part of the wonder. We often think of bodies as slow to change. Yet migration favors creatures that can shift quickly between modes. Travel mode and refueling mode demand different tools, and the body supplies them at the right time. This is not a small adjustment. It is a coordinated rebuild that happens in a matter of days. Arrive, eat, restore. The journey continues, but the body keeps pace. Migration can reshape an animal's muscles, heart, and blood chemistry. A long journey is not only about willpower, it is about physics and physiology. For some migrants, flight or sustained swimming requires more oxygen delivery, more efficient energy use, and stronger endurance tissues. That can mean enlarging key muscles, increasing heart performance, and changing the blood's capacity to carry oxygen. These are not cosmetic changes. They are functional upgrades that make repeated long-distance movement possible. The animal becomes tuned for a season of effort. Then later, it can shift again when the demands change. This is one reason migration can look effortless from far away. The traveler has been preparing long before it takes the first step or wing beat. It also means that migration is written into the body, not just the behavior. The route is not the only thing that is mapped. The internal machinery is scheduled too, rising to meet the journey's demands and easing back when the travel season ends. Some birds use Earth's smell, forming an odor map of home. For them, the air is not empty. It is layered with information. As winds move over forests, fields, coastlines, and cities, they pick up signature mixtures of scents. A bird can learn those patterns over time and then use them like a map, especially when landmarks are far below or hidden by weather. It is not about sniffing one familiar flower. It is about recognizing whole regions by the blend of what the wind carries. That can help a migrant confirm where it is along a route or fine-tune the final approach toward a breeding area. It also means that a shift in wind direction can feel like turning a page. The world suddenly smells different, and the bird updates its sense of place. Navigation becomes something you can breathe in. And that idea is astonishing. Pigeons can detect infrasound, low rumbles that hint at direction. Some sounds are so deep you do not consciously hear them, yet they can travel for huge distances. Infrasound can come from ocean waves crashing, from storms, or from wind moving across mountain ranges. A pigeon can pick up these long rolling signals and use them as a kind of background landmark. It is like living with a low, steady hum that tells you where the coast is or where a range of hills begins, even when the view is blocked. This may help explain why pigeons can orient from unfamiliar places, then set off with confidence. The sky can look the same in every direction, but the soundscape is not the same. It carries direction in a subtle way. When people talk about animal navigation, they often think of sight first. With pigeons, the map may also be something you feel through vibrations, as if the planet is quietly humming its own coordinates. Bees perform migrations too, when colonies relocate to survive. When a honeybee colony becomes too large, it can split, and that moment turns into a traveling drama. Thousands of bees leave with a queen, swirling into the air like a living cloud, then settling into a temporary cluster that hangs from a branch or a wall. While the mass waits, scout bees fan out to search for a new home, checking cavities for space, dryness, and safety. Then the scouts return and communicate, and the group gradually converges on a decision. When they lift off again, it is not random. It is a coordinated flight toward a chosen site, sometimes far from where they started. This is migration on a neighborhood scale, but the stakes are huge. A wrong address can doom the colony. A right one creates a new city of bees built from movement and collective choice. Army ants migrate on foot, building living bridges as they go. Their world is the forest floor, yet they can still travel like an unstoppable tide. When an army ant colony moves, it can form long trails of workers that sweep through leaf litter in search of prey. If the path meets a gap or a stream edge, the ants do something that feels like engineering. They link bodies, gripping legs and mandibles to form temporary bridges and platforms. Other ants run across them, and the structure reshapes itself as traffic changes, thickening where needed and thinning where it is not. The colony can also move its young and queen during these marches, keeping the entire society mobile. This is not a wonder. It is an organized relocation that can transform whatever it passes through. Small creatures are often described as simple. Army ants show how complex migration can be, even when every step is taken on tiny feet. Locust swarms can travel with weather systems, expanding like storms. A locust swarm is not just a crowd. It is a moving force that can rise, drift, settle, and lift again with the rhythm of wind and heat. Warm air can help swarms take off, and shifting weather can carry them over long distances in a short time. As they travel, their density can change fast. A scattered group can gather into a thick wave, and the wave can spread again as it searches for new food. This makes the swarm feel storm-like, because it is shaped by atmospheric conditions, and it can arrive suddenly. When it lands, the landscape can be stripped quickly, and the swarm moves on to the next patch. What is most unsettling is how the behavior can flip. Under certain conditions, locusts shift into a form that favors grouping and travel. Migration becomes not only movement through space, but a transformation of the traveler itself. Waterfowl migrations can spread plant seeds across continents. A duck lifts off from one wetland and lands in another, and the trip can carry more than feathers. Seeds can cling to muddy feet and plumage, hitching a ride without any intention from the bird. Other seeds survive a journey through the digestive tract, then return to the world in a new place, still able to grow. That means a chain of lakes and marshes can become connected by travelers that do not even notice the cargo. Over many seasons, this helps plants colonize new waters, recover after drought, and maintain genetic mixing between distant sites. It also turns stopover wetlands into crossroads, because birds from different regions gather there and move on in different directions. When you see a calm pond, it can feel isolated. Waterfowl migration reveals a different truth. Many wetlands are linked by invisible roots, and seeds are quietly riding those roots. Some fish transport nutrients from ocean to forest inside their bodies. Consider an anadromous fish, like the American shad. It grows large in the ocean, feeding in salty water where nutrients are plentiful. Then it returns to freshwater rivers to spawn, carrying that ocean-derived energy upstream. Once there, its presence feeds river predators and scavengers, and its waste adds nutrients to the water itself. In some places, spawning runs are intense enough that the river changes for a while because the system receives a seasonal pulse of richness. That pulse does not stay in the channel. Insects can build their lives on it, and then emerge into the air where birds and bats feed. Plants along the banks can benefit when nutrients settle into sediments during floods. This is migration as a nutrient conveyor belt. The fish is not only seeking a birthplace for its young, it is also delivering ocean calories into inland habitats, and the forest around the river can feel the difference. Bears and eagles move those nutrients farther, leaving them on land. When fish runs arrive, some predators do not eat in one place and stay there. They grab a catch and carry it away, sometimes into thick vegetation or up onto higher ground. An eagle might tear pieces loose and drop scraps. A bear may drag a fish into the woods to eat in privacy. Each trip moves marine nutrients out of the river corridor and into soil, roots, and the mouths of insects that clean up what remains. Over time, repeated seasons can enrich patches of land far from the water's edge. It also spreads the benefits around. So it is not only the river that gets fed. This is a hidden part of migration's impact. The traveler brings energy inland, and then other animals redistribute it like couriers with messy packages. The forest becomes linked to the sea through a chain of appetites, each step carrying nutrients farther into the landscape. Migrants can fertilize landscapes just by passing through. A herd pauses to graze, and the ground receives a pulse of nutrients through droppings and urine. A flock settles into a wetland for a night, and the water chemistry shifts slightly with the new inputs. These changes can sound minor, yet they can matter because they arrive predictably and they arrive in bulk. Plants respond to nutrients. Microbes respond to nutrients. Insects respond to the plants, and birds respond to the insects. That is how a passing group can trigger a cascade without building anything permanent. Migration creates moving hotspots of fertility, and those hotspots can influence where growth is strongest in the following weeks. This effect is not only about large animals. Even dense gatherings of seabirds can enrich coastal soils over time through repeated use of roosting sites. It is an elegant idea. Travel does not have to be destructive. Sometimes movement feeds the world, leaving behind a trail of richer ground. Entire food webs can wait for migrants, then surge into action. In some places, the year feels like it has a switch. Before the migrants arrive, predators may be scarce, insects may be few, and many animals conserve energy. Then a traveling pulse appears and everything reacts. Raptors gather along ridges when birds tumble through. River predators become active when fish runs begin. On the coast, scavengers and hunters appear when seasonal arrivals make food suddenly abundant. The response can be so rapid that it feels rehearsed, because it is. Over evolutionary time, many species have learned that waiting can be smarter than searching. Migration turns scarcity into a brief season of plenty. And that season can determine who breeds successfully and who does not. It also creates timing chains where one arrival triggers another response down the line. The landscape becomes a stage with cues, entrances, and exits, and the travelers are the signal that the show is starting. In some regions, migration is timed to moonlight and tides. Along certain coasts, the calendar is not written in months, it is written in nights. Moonlight changes how predators hunt and how prey hides. And tides decide which flats are exposed and which channels run deep. For traveling animals, that can make a single evening feel like a doorway that opens, then shuts again. Some swimmers wait for high water that lifts them over shallow bars. Some shoreline travelers need low tide that reveals feeding ground like a pulled-back curtain. Even the brightness of the moon can matter. A darker night can mean safer movement for animals that fear being seen from above, while a brighter night can help those that rely on vision to navigate. When you think of migration, you might picture a compass and a long road. In many places, the most important guide is the sky's clock and the sea's pulse.
Horseshoe crabs gather to spawn, feeding shorebirds on a tight schedule.
On certain beaches, the sand becomes a seasonal meeting place. Horseshoe crabs arrive to lay eggs, and the shoreline suddenly holds an energy-rich food source that does not last long. Migrating shorebirds time their stopover to this moment because they need to gain weight fast before a demanding flight. The birds do not snack politely. They feed with urgency because every hour matters and because the tide will soon change the menu. This connection is more than coincidence. It is a lifelink between a creature that has existed for an astonishing span of time and birds that must refuel on the edge of the ocean. If storms reshape the beach, or if spawning numbers drop, the birds can lose a critical pit stop. What looks like a busy night at the waterline is also a survival contract between two travelers signed by timing. Coral reef fish larvae drift like migrants, then settle miles away. A reef can seem like a fixed city, yet many of its residents begin life as tiny wanderers. After spawning, larvae enter the open water, where currents become their transport. They may travel far from the reef they came from, passing through blue space that offers few familiar cues. Then comes the astonishing part. When the time is right, these larvae can locate suitable habitat and return to the reef zone, sometimes guided by sounds and chemical traces carried through the water. Settlement is not random. The young fish must choose a home that offers shelter, food, and a chance to grow without being eaten immediately. This drifting stage connects reefs like neighborhoods linked by hidden roads. It means one reef can help replenish another, and it means damage in one region can ripple outward through the next generation. Migration is happening, even at the scale of a drifting speck. Some reef fish return to the same spawning sites year after year. For certain reef fish, reproduction is a journey with a destination.
Adults leave their everyday feeding areas and travel to specific gathering points, often timed to seasons or lunar cycles. At these sites, many individuals arrive together, and the water can fill with activity that lasts only a short window. The advantage is not just romance. Spawning together can overwhelm predators through sheer numbers, and it can increase the chance that eggs and sperm meet in the moving sea. Returning to the same place also means the location has proven itself, perhaps through currents that carry young toward habitats where they can survive. This fidelity can be so strong that if a spawning site is disturbed, the population can struggle even if nearby reefs still look healthy. It is a reminder that habitats are not only about where animals live, they are also about where crucial events happen, and those places can be surprisingly few. Natal homing can be so precise, siblings return to the same stream bend. There are rivers where the return is not just to the correct watershed. It is to a particular curve, a specific patch of gravel, a familiar flow pattern that exists like an address. Animals that home this precisely are not relying on a single clue. They are combining information that becomes more detailed as they approach, until the finer choices happen in water only meters wide. This accuracy matters because not every part of a river is equal. Some spots have the right oxygen levels, the right current speed, and the right protection for eggs or young. Returning to a proven birthplace can raise the odds that the next generation starts in a place that works. The emotional effect on humans is hard to ignore. We tend to think of memory as personal and conscious. Natal homing shows another kind of memory, built into biology and reinforced by the landscape itself. Many migrants use landmarks, but they also correct for wind drift. A straight route on a map is rarely a straight route in the air. Wind pushes, sometimes gently and sometimes with real force. And a traveler that does not compensate can end up far off course. Many migrants solve this by blending what they see with what they sense. A coastline, a mountain chain, or a river valley can provide a visual guide. Yet the animal still has to handle sideways drift. Some choose headings that intentionally angle into the wind, so the push cancels out and the path stays true. Others adjust on the fly, correcting again and again as conditions change. This is one reason migration can look calm from below. The traveler is constantly negotiating invisible forces. It is also why storms can be so dangerous. A powerful wind can turn a sensible route into a long detour, and that detour can cost precious energy. Migration is not only navigation, it is physics corrected in real time. Young birds can inherit routes without ever being taught. Some first-time migrants leave with no experienced guide, yet they still head in the right general direction. That can happen because elements of the route are encoded as instinct, like a built-in program that says when to depart and which broad heading to follow. It does not mean the journey is perfect. Young birds can make mistakes, and many do not survive the first attempt. Still, the fact that a useful route can appear without training is astonishing. It means evolution has shaped behavior with enough precision to point a small animal toward a distant region it has never seen. Over time, experience can refine that inherited plan, adding local knowledge about stopovers and hazards. This mix of instinct and learning creates a powerful system. A species can keep migrating even when generations are separated by vast distances. The map is not only in the world. Part of it is carried within the traveler. Other species learn routes culturally, like a shared family tradition. In these migrations, knowledge is not just genetic, it is social.
Young animals travel alongside older ones and pick up details that cannot be coded easily, like where to rest safely, where to cross a dangerous stretch, and which valleys offer reliable food during bad weather. Over years, that shared route can become a cultural pathway, passed along much like a story that is told again and again until it becomes community memory. This can make migrations resilient because the group can adjust and then teach the new version. It can also make them fragile because losing the carriers of knowledge can erase hard-won information. This is especially striking in animals with long lives and strong social bonds. Migration becomes something the group does together, not just something individuals attempt alone. It also changes how we think about conservation. Protecting a species can mean protecting its teachers, not just its habitat. In cranes, elders can teach safer paths to younger birds. A crane migration can look graceful, but the learning behind it can be intense. Young cranes benefit from following experienced birds that know how to use rising air, where to avoid dangerous weather, and which stopovers offer space to rest without constant threat. This is not a lecture, it is guidance through example. The young watch when the flock lifts off, how it circles to gain height, and how it chooses a route that balances distance with safety. Over time, those choices become familiar, and the next generation can carry them forward. The idea that a migration route can be taught like a skill is powerful. It means the journey is not only instinct, it is education. It also means disruption can hit harder than we expect. If elders are removed from a population, the young may still move. They may do it more dangerously, and the losses can climb. The path through the sky can depend on memory held in living bodies. Losing experienced leaders can change an entire migration. In a migration that relies on learning, leaders are more than strong individuals. They are libraries. They carry knowledge of timing, terrain, and safe passage that the group depends on when conditions turn harsh. When those leaders disappear, the route can become less efficient or more risky, and the group may fragment or hesitate at critical decision points. The most sobering part is that the change may not be obvious at first. The animals still depart, they still travel, yet small mistakes compound, and a once reliable journey can begin to fail. This effect can be especially strong in long-lived species, where experience accumulates over many seasons. It is also a reminder that migration is not just a line between two places. It is a system of information. Remove key holders of that information, and the system can wobble. Protecting migration sometimes means protecting elders, because they are the ones who remember the safest way through a shifting world. Some animals migrate to give birth, not to find food. For many species, the best nursery is not where the meals are. It is where danger is lower, water is calmer, or temperatures are kinder to newborn bodies. That can mean traveling away from rich feeding grounds toward places that look almost empty at first glance. The payoff is safety. Calves or pups arrive into conditions that reduce hypothermia, reduce predators, or offer sheltered terrain where small legs can keep up. These migrations can be timed with astonishing precision because birth is not flexible. If the group arrives late, newborns face the wrong weather. If they arrive early, adults may run short on energy before the babies even appear. This creates a powerful tension in the journey. The adults carry the cost of travel so the young can start life with better odds. Migration becomes a moving cradle built from timing and risk management. Elephant seals travel far to feed, then return to the same beaches. Their year is split between two very different worlds. At sea, they range widely to hunt in deep water, building the reserves they will need for the months ahead. Then they come back to land, often to remarkably specific haul-out sites, where breeding and molting happen in crowded, noisy colonies. Returning to the same beaches matters, because the location offers familiar access points and social structure that has been shaped over many seasons. On land, they fast for long stretches, relying on the energy earned during their feeding migrations. This makes the travel feel like an investment. Every successful hunt at sea becomes future time ashore. It also turns their bodies into records of the journey, thick with stored fuel and marked by encounters in the ocean. When they arrive, the beach is not a finish line. It is the next chapter, and the migration is the hinge that makes it possible. Many seabirds commute between feeding zones and nesting cliffs for months. Some migrations are not a single departure and arrival. They are repeated commutes that play out across an entire season. A seabird may nest on a steep headland, then fly out day after day to feeding areas that can be far beyond the horizon. Each trip must balance urgency and caution. The bird needs enough food for itself and for a chick that cannot travel. Yet the ocean is unpredictable, and winds can turn a routine flight into a struggle. This rhythm creates a life built on distance. The nest becomes a fixed point, and the sea becomes a shifting pantry. Over weeks, the same individual may trace the same understanding of currents and prey movement, refining a route through experience. When you watch a nesting colony, it can feel stationary. In reality, it is powered by constant motion, and the ocean and cliff are linked by thousands of unseen flights. penguins can migrate through water, following shifting bands of krill. On land, penguins look like comedians in formal wear. In the sea, they become fast, focused hunters that treat the ocean like a three-dimensional maze. Their movements can track the places where krill gather, and those places can shift with sea ice, currents, and seasonal changes in productivity. A penguin colony may be tied to a nesting site on shore, yet its feeding range can expand dramatically as conditions change. Travel becomes a response to where the food concentrates, not to where the coastline looks familiar. This can create migrations that feel fluid, because the best hunting grounds can slide across the map as the year turns. It also means penguins are reading signals we rarely notice, like water temperature and the presence of microscopic blooms that support krill. When they leave the beach and vanish into the waves, they are not simply swimming away. They are entering a moving food landscape, and they are following it with precision. Arctic foxes can roam astonishing distances across sea ice. In the high Arctic, the ground itself can disappear into a flat, white expanse, and that does not stop an Arctic fox. Sea ice becomes a bridge between worlds, connecting islands, coastlines, and hunting grounds that would otherwise be separated by open water. A fox can travel across this shifting surface in search of carcasses, bird colonies, or new territory. And the distances can be far larger than most people would expect for an animal that looks so small. The risks are real. Ice can fracture, storms can erase tracks, and the landscape offers few places to hide. Still, the fox explains something important about migration. Movement is not always a grand seasonal parade. Sometimes it is a determined roaming across extreme terrain, guided by opportunity and survival. When sea ice patterns change, those hidden routes can change too. The fox's ability to range so widely shows how life can treat even the harshest environments as connected, as long as a path exists.
Reindeer migrations can open paths that other animals later follow. A large herd does more than move through a landscape. It shapes it. As reindeer travel, they trample snow, compressing it into firmer surfaces that can become easier for smaller animals to cross. They can also break crusts that would otherwise block access to lichens and low plants, creating openings that linger after the herd has passed. In that way, migration can be a form of ecosystem engineering. The herd is not building a road on purpose, yet its passage can create a temporary corridor of access, especially in winter conditions that make travel difficult. Predators may use these corridors too, because moving efficiently matters when calories are scarce. This is a powerful idea. A migration can ripple outward, helping or harming others depending on timing and density. The reindeer are following their own needs, yet their route can become a moving influence that changes who can travel, who can feed, and who can survive in their wake. Zebras can choose longer routes to reach better grazing. A straight line is not always the smartest path. For a zebra, the goal is not simply to arrive somewhere else. The goal is to arrive in a place where grass is worth the effort and where the risks along the way do not outweigh the reward. That can mean taking detours that look inefficient on a map yet make perfect sense in real life. Some routes avoid areas with heavy predator pressure. Others swing toward regions that received recent rain, where grass is tender and water is available. By choosing longer paths, zebras can also spread their grazing across a wider region, which can reduce competition within the herd. This decision-making reveals migration as a flexible strategy, not a rigid instinct. The animals are responding to conditions, and those conditions change year by year. When you picture a herd moving, it can look like one simple direction. Up close, it can be a series of choices that trade distance for safety and better food. Migration routes can form highways visible from space through vegetation changes. When large numbers of animals use the same corridor year after year, the land can tell the story. Repeated grazing can keep certain bands of vegetation shorter. Repeated movement can compact soils in narrow paths. Nutrients deposited along the route can enrich some patches, while other areas recover. Over time, these differences can become patterns that stand out in satellite images, especially across open regions where plant growth responds quickly to pressure. It is like seeing a footprint that is too large for any single animal to make. What makes this so striking is the time scale. The highway is not painted or paved. It is written by many seasons of movement, and it can persist as long as the migration continues. This also means that when migrations are disrupted, the land can change again, and the old corridors can fade. A satellite view can turn migration into something you can see at a planetary distance, as if the animals have drawn lines across the Earth. Rivers can become migration corridors, guiding animals like moving roads. A river offers more than water. It offers direction. It cuts through forests and plains, and it provides a continuous pathway that is hard to lose, even when the surrounding landscape is confusing. For many species, following a river can mean reliable drinking access, predictable vegetation, and a chain of habitats that support rest and feeding. Some animals use river valleys as travel lanes during seasonal movement because the terrain is often gentler and the route avoids steep climbs. For flying migrants, rivers can also be visual guides that stand out from high above, especially in regions where other landmarks repeat. Yet rivers are not always safe. Floods can block crossings, and narrow corridors can funnel predators and prey into close contact. That tension makes river migration dramatic. The same feature that helps you travel can also concentrate risk. Still, the power of a river corridor is hard to deny. It turns a vast landscape into a route with edges, with cues, and with an unbroken sense of forward. Mountain passes can funnel millions of creatures through a single gap. Mountains can be walls to many migrants. Flying over high peaks can be dangerous because air can thin, winds can spike, and weather can change quickly. For land animals, steep slopes can drain energy and expose travelers to danger. So a pass becomes a rare doorway, a place where the terrain offers a lower crossing and where movement becomes concentrated. This can create astonishing scenes. Birds can stream through a single gap in steady waves. Insects can be carried along the same corridor by winds shaped by the mountains. Even predators learn these choke points, because where travelers funnel, hunting can be efficient. The pass becomes a meeting of geography and biology, where the shape of rock directs the shape of life's movement. It is also a reminder that migration is not happening everywhere equally. Sometimes it is happening intensely in one narrow place, because that is the only way through. A single gap can connect whole regions, and millions of journeys can depend on it. Some migrations are vertical, from forest floor to canopy. In a forest, the biggest journey can happen without traveling far across the map. Many animals move upward and downward through layers that feel like different worlds. The canopy can offer ripe fruit, fresh leaves, and warm sunlight, while the understory can offer shelter, moisture, and safer hiding. Some creatures climb to feed at night, then return lower by day.
Others reverse that pattern because heat and dryness can become dangerous in the upper branches. Even insects and spiders can shift their altitude with the season, following where food appears and where predators are fewer. This kind of movement changes who meets whom in the forest, because the canopy is not just higher ground, it is a separate neighborhood with its own rules. When you stand beneath trees and see stillness, remember that migration may be happening straight above you in quiet, purposeful climbs. Alpine animals migrate uphill in summer, then downhill for winter shelter. In mountain country, altitude is a shortcut to a new season. As summer arrives, the higher slopes green up later, and that delayed growth can stay tender when lower meadows have already dried or toughened. Many animals climb to take advantage of that freshness and to escape insects and heat that can plague them below. Then winter changes the bargain.
Snow deepens, winds sharpen, and food becomes buried. Moving downhill can mean reaching forests that block wind, slopes that shed snow, and valleys where warmth lingers a little longer. This is not a casual stroll. The timing matters because a sudden storm can trap a group above the tree line, and an early descent can mean competing for limited resources too soon. Mountain migration is a seasonal trade between opportunity and danger, measured in elevation rather than latitude. A few thousand feet can be the difference between abundance and hardship. Even snails migrate following moisture gradients across small landscapes. A snail's world is built from water balance. Too dry and movement risks dehydration. Too wet and feeding can shift as plants and fungi change. Some snails respond by traveling toward better humidity, tracking shaded ground, damp leaf litter, and the edges of puddles or streams. The distances can be small in human terms, yet enormous in snail terms, and the timing can be urgent after sun and wind strip moisture from the surface. This migration can also shape where snails lay eggs, because young need stable conditions to survive. It is easy to overlook this as random wandering, but the path often has a pattern. Follow the damp places, pause in shelter, and move again when the ground becomes safe. Snail migration is a reminder that travel does not require speed. It requires purpose and a world that rewards the right direction. Amphibians can migrate to the same pond even after years away. For many frogs, toads, and salamanders, breeding is not a vague idea of returning to water. It is returning to a specific water. Adults spend much of their lives away from the pond, hidden in forests, fields, or underground refuges. Then a season arrives when the urge to return becomes overwhelming. They travel across land that can be dangerous, crossing dry patches, open ground, and sometimes roads. The accuracy can be startling. Individuals may find the same pond they used before, even if they have not visited it for a long time. The benefit is that a familiar pond has proven it can hold water long enough for eggs and larvae to develop. This creates a hidden map of the landscape, one that only becomes visible when the migration begins. A quiet pond can be a destination with a history, and the night of arrival can feel like a reunion that happens without invitations. Some frogs return on the first warm rain, as if scheduled. A warm rain can flip a switch. The soil softens, the air turns humid, and the risk of drying out drops fast. For some frogs, that is the signal to move, and the timing can be so tight it feels like an appointment. They emerge from hiding, then travel toward breeding sites with a focus that ignores much of what would distract them on ordinary nights. The rain also changes sound. Calls carry differently in damp air.
and the chorus can build quickly as more frogs arrive. This is not simply romance in the rain, it is strategy. Eggs and tadpoles need water, and many breeding places are temporary. Arriving early can mean claiming the best spots, yet arriving too early can mean finding a basin that is still dry. The first warm rain often hits the sweet spot. It turns land into a safe corridor, and it opens the season in a single dramatic night. The Serengeti migration can be guided by lightning-triggered rain. On the plains, rain is not just water, it is the beginning of grass. During the dry season, herds spread out and search because the landscape offers less and less. Then storms begin to form in the distance, and lightning strikes can signal where rain is falling now or where it fell recently. That matters because new growth can appear quickly after moisture returns. Animals that can sense the change through smell, sound, or the taste of fresh shoots gain an advantage by moving toward better grazing before the old areas are exhausted. The root is not a single fixed loop stamped into the earth. It converses with weather because rain does not land the same way every year. This makes the migration feel alive, like a conversation with the sky. Lightning flickers, storms shift, grass responds, and the herds follow, turning weather into movement across a vast landscape. Many species stop at the same refueling sites, like living airports. Long journeys often require a chain of safe places, and those places can become famous in the animal world. A wetland, a reef edge, a stretch of coastline, or a valley can offer the right mix of food and shelter at the right time. Travelers arrive, feed hard, rest, and then depart again, sometimes in such numbers that the site feels temporarily overrun. These stopovers are not optional treats. They can be the difference between having enough energy for the next leg or failing before it is done. The timing can be precise because food booms can be brief. Insects hatch, berries ripen, fish gather, and then the moment passes. That is why a refueling site can serve many species at once, each one tuned to a slightly different menu. Think of these places as biological terminals. They are where the journey gets paid for, meal by meal. Removing one stopover wetland can ripple across continents. When a key wetland is drained or degraded, the loss is not local in its impact. Migrants that depended on it may arrive at the next stop hungry, late, and stressed, and that can reduce survival, even if the rest of the route looks intact. Some will attempt longer jumps without enough fuel. Others will crowd into smaller remaining wetlands, which can increase competition and spread disease. The ripple can reach breeding grounds because fewer adults arrive in condition to reproduce successfully. It can also reach wintering areas because the population size changes months later, far from where the wetland was lost. This is the brutal arithmetic of migration. A journey that seems sturdy can be fragile if it relies on a few crucial stepping stones. Protecting migration often means protecting links, not just endpoints. A single wetland can be a hinge for an entire flyway, and when it breaks, the movement of life can break with it. Light pollution can pull migrants off course, especially on foggy nights. Artificial light changes the night sky, and many migrants are adapted to natural darkness. Bright city glow can attract and disorient travelers, drawing them into places they did not intend to enter. Fog makes it worse because light scatters and creates a glowing ceiling that can confuse orientation and depth.
Birds may circle within that lighted haze, burning energy they cannot easily replace. They can descend into hazardous airspace where obstacles and exhaustion become real threats. Even when they escape, the delay can push them into poorer weather or reduce their time to feed at dawn. This is not just about big cities. Small clusters of lights can matter if they sit along major routes. The hopeful part is that lighting choices can reduce harm, especially during peak migration seasons. Darker skies restore the natural cues migrants evolved to trust, and that can turn a dangerous night back into a safe passage. Tall buildings can become deadly obstacles along urban flyways. A glass tower can look like open sky because it reflects clouds, trees, and dawn light. For a migrating bird, that illusion can be fatal. Collisions often happen during night travel and early morning, when birds descend to rest or when weather pushes them lower. Windows can also create a trap effect, with bright interior lights drawing birds toward the structure, then reflections preventing them from recognizing the barrier. Cities placed along major routes can concentrate this risk because large numbers pass through the same airspace. The tragedy is that many impacts are preventable.
Simple changes like turning off unnecessary lights at night, using bird-friendly glass patterns, and shielding bright fixtures can reduce collisions dramatically. Urban migration does not have to be a gauntlet. With thoughtful design, cities can become safer corridors rather than obstacle fields. The sky belongs to travelers too, and our buildings shape the routes they must survive. Wind turbines can be safer when placed away from key corridors. A turbine is not dangerous everywhere in the same way. Risk rises when blades sit in the exact airspaces that migrants use most, such as ridgelines, mountain gaps, and coastal funnels where birds concentrate. If a turbine is moved even a short distance away from those corridors, the danger can drop because the traffic thins. Timing matters too. Migration does not happen evenly across the year, so operators can reduce risk by slowing or stopping turbines during heavy movement or during low wind nights when bats are most active. This is where careful mapping becomes powerful. Radar, acoustic monitors, and tracking data can reveal when and where the sky fills with travelers. Then design choices can follow the evidence. Energy and wildlife do not have to be opponents. When placement and operation respect migration patterns, the same wind can power homes while leaving safer passage for the moving lives above. Underwater noise can disrupt whale movements, masking important cues. In the ocean, sound travels far, and many whales rely on it the way we rely on sight. Their calls can help maintain contact, locate companions, and make sense of the seascape. When shipping, construction, or other loud activity raises the background noise, those signals can be harder to detect. That can force whales to call louder, call more often, or change their routes to avoid noisy regions. A detour might not sound serious until you imagine a long migration that already runs on tight energy budgets and precise timing.
Noise can also mask natural cues, such as the sounds of waves near shorelines or the movements of prey. The ocean becomes less readable. The hopeful part is that noise can be managed. Slower ship speeds, route adjustments, and quieter technology can reduce the acoustic fog. When the sea grows calmer in sound, whales gain back a clearer world to travel through. Climate shifts can make migrants arrive before food is ready. Migration is often timed to a moving feast, and that feast can be seasonal: insects, fresh leaves, or plankton blooms. When temperatures warm earlier,
those food peaks can happen sooner. Some migrants respond by departing earlier too, but not all species can shift fast enough. A traveler may arrive on schedule by its own internal calendar, then find that the richest moment already passed. That mismatch can be brutal. Adults may struggle to regain energy after arrival, and chicks or calves may grow during a lean period when food is scarce. The problem can also work the other way. A late spring can delay food while migrants arrive expecting abundance. This is one of the sharpest edges of climate change, because the route may still exist and the destination may still look familiar. Yet the timing link between traveler and meal can quietly break. Migration depends on calendars, and the climate is rewriting them. Some populations now migrate shorter distances because winters are milder. When cold seasons soften, some animals do not need to travel as far to find survivable conditions. A bird that once had to cross a continent to avoid freezing nights may now find food and open water much closer to its breeding range. That can sound like good news, because shorter travel means less exposure to storms and less energy spent on movement. Yet, it can also change competition and disease dynamics, because more individuals remain in the same regions year-round. It can reshape local ecosystems too. Predators that once relied on migrants may see different patterns of availability, and plants may be grazed at times they were not before. Shorter migration can also reduce the use of traditional stopover habitats, which may then be lost because they seem less important. The route does not only serve the traveler, it supports a network of places. When distances shrink, the map of ecological connections can shrink with them. Others travel farther, chasing habitats that are sliding forward. For some migrants, the issue is not comfort, it is habitat itself. As temperatures and rainfall patterns shift, the zones that support certain plants and prey can move northward or upward in elevation. A species may be forced to extend its journey simply to reach the same kind of conditions it once found closer. That can turn a manageable migration into a more demanding one. Longer flights or longer treks require more fuel, more reliable stopovers, and more chances for things to go wrong. It can also push animals into landscapes filled with new hazards, including unfamiliar predators and human-built barriers. The strange part is that the destination can still feel like home in function, even if it is not the same place on the map. The animal is chasing a moving target. Migration becomes a pursuit of climate space, not of geography. When habitats slide, travel must stretch to keep up. Migration timing can evolve quickly within only a few decades. We often imagine evolution as slow, but timing is a trait that can shift fast when the pressure is strong. In many migratory species, individuals vary. Some depart a little earlier, some a little later. If conditions change, such as earlier springs or altered storm patterns, the individuals whose timing fits the new reality may survive and reproduce more successfully over repeated generations. That can push the population schedule in a new direction. This does not mean the change is effortless. There can be years of confusion when old timing rules fail, and there can be trade-offs that hurt in other parts of the life cycle. Still, the speed can be surprising, especially in species with short generation times. It is like watching a living calendar adjust its pages in real time. Migration is not only behavior, it is a moving trait shaped by selection, and the environment can turn the dial faster than we expect. Some species have lost migrations entirely, becoming year-round residents. When food becomes available through winter, or when new shelter appears, some animals stop traveling and stay put. In cities, that can happen because warm microclimates and steady human food sources remove the old need to move. In agricultural regions, it can happen because fields provide reliable feeding long after wild resources would have faded. Over time, a resident lifestyle can take hold.
Individuals that remain may avoid the dangers of long travel, and they may start breeding earlier because they are already on site. Yet, the shift can also trap a population if conditions swing back, because the knowledge and instincts of migration can fade. A species that once connected distant ecosystems can become local, and the broader network loses that moving link. Losing migration is not always a visible catastrophe. Sometimes it is a quiet rewiring of life's rhythm. The seasons still turn, but the traveler no longer answers them with a journey. New migrations can appear when humans create reservoirs or farmland. When people build large reservoirs, they create permanent water where there may have been seasonal scarcity. When farmland expands, it can provide dense, predictable food. For some species, these changes act like new magnets on the map. Birds may begin traveling to winter in places that did not exist as habitat before. Or they may shift routes to follow harvest cycles and flooded fields. Over time, these patterns can become regular. Young animals grow up using the new stops, and what began as opportunistic movement becomes a new tradition. The twist is that these human-made habitats can be unstable. Water levels change with management decisions, and crops change with markets. A new migration can flourish and then collapse if the resource disappears. This shows how flexible migration can be. It is not always ancient and fixed. It can form quickly when a new resource appears, and it can bind wildlife to human choices in ways we rarely notice. Dams can block ancient fish routes, rewriting ecosystems upstream. For migratory fish, a river is not just water, it is a corridor to spawning habitat. A dam can turn that corridor into a wall. When adults cannot reach upstream breeding grounds, populations can crash, and the effects can spread outward. Predators that once relied on seasonal fish runs lose a food pulse. Gravel beds that were once cleaned and stirred by spawning activity can change in structure. Even the flow regime can shift because reservoirs alter temperature and sediment movement. Downstream, juveniles may struggle to pass turbines or spillways, and their journey can become slower and more hazardous. Fish ladders and bypass systems can help, but they do not always restore the full route or the full timing. A blocked migration is not only the loss of a traveler, it is the loss of a seasonal delivery of energy and disturbance that rivers evolved around. When the route closes, the river becomes a different ecosystem. Wildlife crossings can reconnect routes, reducing collisions and restoring movement. A highway can slice through a migration corridor like a fence, and animals pay the price in injuries, deaths, and broken access to seasonal habitat. Wildlife crossings are one way to stitch the landscape back together. Overpasses planted with vegetation can feel like natural ground to deer, elk, and other large mammals. Underpasses can provide safer passage for smaller animals that prefer cover. When fences guide wildlife toward these structures, the effect can be dramatic. Collisions can drop, and animals regain access to feeding and breeding areas that were effectively cut off. This is not only a safety project for drivers, it is a restoration of movement which can help maintain genetic exchange between populations and reduce the pressure on crowded habitats. A successful crossing is an invisible success story.
The animal passes safely, the road stays quiet, and the migration continues as if the barrier was never there. It is human infrastructure learning to make room for older routes. Even microbes migrate, riding dust storms across oceans. A gust over dry ground can lift more than sand. It can lift living cells, fungal spores, and tiny bits of life you could never spot with your eyes. Once airborne, these passengers can travel for days, crossing seas and continents inside dust blooms that satellites can track. Some microbes survive harsh sunlight and cold because their tough outer layers help them endure the ride. When the dust finally settles, it can seed new environments with new arrivals, sometimes onto mountain snow, coral reefs, or faraway farmland. That does not mean every microbe thrives. Many perish, and that is part of the story too. Yet enough survive to make dust a global delivery system for life. Migration is not only about wings and fins. It can also be a planet-scale shuffle of the smallest travelers moving on the breath of the earth. Phytoplankton blooms drift, and migrating grazers follow them like herds. In the ocean, food can appear as a moving patchwork. When sunlight and nutrients align, phytoplankton bloom, turning water into a rich soup that feeds almost everything above it. Those blooms do not stay put. Currents stretch them, spin them into eddies, and slide them along coasts. Many grazers track these drifting banquets, from tiny filter feeders to larger animals that depend on the chain of life that blooms create. The effect can feel like an underwater savanna, where the grass is microscopic and the pastures are always shifting. Predators then follow the grazers, because where food concentrates, hunting becomes efficient. This movement links physics to biology. A current line can become a feeding lane. A swirling eddy can become a temporary dining hall. Migration is not always a march toward a fixed destination. Sometimes it is the art of staying near a moving meal. The ocean's moving layers create highways that only some animals can use. The sea is stacked in layers that behave differently. Warm water can slide above cooler water. Saltier water can sink below fresher water. Each layer can flow in its own direction, like overlapping rivers you cannot see from the surface.
Animals that can choose depth gain access to these hidden routes. A strong swimmer might drop into a layer that carries it forward faster, then rise again to feed where life is denser. Others use these highways to avoid predators that patrol a different depth zone. This creates a secret geography where the best route depends on knowing not just where you are, but what depth you are in. It also means two animals in the same spot on the map can be traveling in opposite directions simply because they are riding different layers. Ocean migration can be less like crossing a plain and more like switching lanes on a layered expressway. Some migrants surf currents to save energy, timing departures precisely. A strong current can be a gift, but only if you meet it at the right moment. Many marine migrants time their travel to ride predictable flows, such as seasonal currents or tide-driven streams that speed up and slow down on schedule. Instead of fighting the ocean, they let it carry them, then use their own effort only when steering is needed. This can stretch stored energy and reduce the time spent exposed in open water. Timing becomes a skill. Leave too early and you battle the wrong flow. Leave too late and you miss the strongest push. Some animals may wait, feeding and resting until conditions align.
then launch into a period of rapid progress. It can feel like catching a train rather than walking the whole way. This strategy also explains why migration routes can look oddly curved. The path follows moving water, not a straight line. In the sea, the shortest route is often the one that moves. Navigation can mix cues: magnetism, stars, sun position, and smell. A migrant rarely relies on a single compass. The world is messy, and good navigation needs backups. An animal may use the sun by day, then switch to the night sky after dusk. It may sense magnetic direction as a steady baseline, then refine its course using odors that hint at coastlines, forests, or familiar waters. Landmarks can help too, especially near the end of a journey, when precision matters most. The marvel is not just that these cues exist, it is that a living brain can blend them, weighting one more heavily when another becomes unreliable. A clear sky can make celestial cues strong. A stormy day can make smell or magnetism more important. Migration is often described as instinct, and instinct is part of it. Yet there is also flexibility, as if the traveler is constantly asking, "What information can I trust right now?" That is how a route survives changing weather, shifting winds, and unfamiliar terrain. When one cue fails, many animals switch to another. A compass can break without warning, at least from the traveler's point of view. Clouds can erase the stars. Haze can hide the horizon. A strong wind can push the body sideways until the usual view no longer matches expectation. Many migrants handle this by switching strategies rather than forcing a failing one. They may pause until conditions improve, or they may change altitude to regain a clearer sense of direction. Some rely more heavily on internal cues when the outside world becomes confusing. Others use the pattern of the land, following coastlines or river valleys until the sky becomes readable again. This adaptability is one reason migration can work at all. A rigid system would collapse the first time weather turns strange. Switching cues also helps explain why migrants can recover after being displaced. They do not need perfect information, they need enough information to correct. The journey becomes a series of updates with course corrections stitched together into a successful route. Some birds recalibrate their compass at sunset, checking the sky pattern. Twilight is a special moment for navigation. The sky changes quickly, and the pattern of light offers information that is easier to read than it is at noon or midnight. Some birds use this window to reset their internal sense of direction, as if they are tuning an instrument before a long performance. The low sun provides a clear reference, and the sky gradients can help confirm orientation before night flight begins. This matters because a small error early in a journey can become a large miss later, especially when wind adds drift. Recalibration at sunset can keep the route stable across many nights of travel. It also makes twilight feel like a quiet ritual, repeated again and again as seasons move. While people watch a sunset for beauty, a migrant may be watching for accuracy. The day is ending, the travel hours are starting, and the sky is offering a final check before the darkness takes over. Young sea turtles can imprint on magnetic signatures of coastlines. A coastline is not only shaped by sand and rock, it also sits within a magnetic landscape that varies subtly from place to place. When sea turtles are young, they can learn the magnetic pattern linked to their home region, storing it as a kind of reference for later life. Years pass in the open ocean, and then adulthood brings a return toward nesting beaches. The ocean is vast, and the targets are narrow. Yet the turtle can use those magnetic signatures as familiar checkpoints,
helping it narrow the search as it approaches land. This is not a simple compass direction. It is more like recognizing a region by its magnetic feel, the way you might recognize a neighborhood by the slope of streets and the sound of traffic. That early imprinting ties memory to the planet itself. The shoreline becomes part of a long-term map carried quietly inside a traveler that spends most of its life far from home. Migration can reduce disease risk by leaving parasites behind.
Staying in one place can let parasites and pathogens build up, because hosts keep returning to the same ground again and again. Movement can disrupt that cycle. When animals leave a contaminated area, some parasites lose their chance to spread, especially if they depend on local conditions or specific intermediate hosts. The traveler may also outpace the life cycle of certain parasites, moving on before the next infectious stage is ready. In that way, migration can act like a reset, lowering the overall burden of infection in a population. This benefit is not guaranteed. Travel is stressful, and stress can weaken defenses. Still, for some species, movement may be part of how health is maintained across seasons. It is an unexpected advantage. Migration is often framed as risky, and it is. Yet sometimes the risk of staying is greater because the invisible enemies of health thrive in stability. Migration can also spread disease when crowded stopovers bring species together. A stopover site can be life-saving, but it can also become a mixing bowl. When many migrants gather tightly, contact increases, and shared water or shared feeding grounds can allow germs to move between individuals. Different populations that rarely meet can overlap for a brief time, creating new pathways for pathogens. Stress can add to the problem, because tired travelers may have fewer resources to fight infection. The consequences can travel onward with the migrants, carrying illness across regions in a way that feels unsettlingly efficient. This does not mean migrants are villains. It means stopovers are powerful nodes where biology becomes concentrated. The same place that offers food and rest can also amplify risk. That is why habitat quality matters. Cleaner water, less crowding, and lower disturbance can reduce transmission. Migration reveals a deep truth about connectivity. What links ecosystems can also link diseases, and the same routes that carry life can carry invisible passengers too. Some predators track migrations, moving like shadows behind the herds. To a predator, a migration is not only a spectacle, it is a calendar of opportunity. Peregrine falcons can position themselves along coastal flyways and ridgelines because those routes funnel tired songbirds into predictable airspace. Instead of searching endlessly, the hunter waits where the sky narrows. On the ground, African wild dogs can shift their ranges to follow moving prey, and their stamina lets them exploit the same long distances that challenge their targets. Even in the ocean, predators can pace traveling schools of fish, staying just close enough to strike when the moment is right. This tracking is not mindless chasing. It is strategy, shaped by experience and by landscape. When prey moves, predators that can move with it gain an advantage. Migration becomes a moving buffet, and the hunters that read the schedule best can turn a hard season into a successful one. Human history includes migrations too, shaping languages, genes, and cities. Long before modern borders, people moved in waves, caravans, fleets, and family groups. Some followed rivers, some followed coasts, and some crossed open water into places that seemed impossibly far away. Each movement carried more than bodies. It carried stories, tools, crops, songs, and ways of seeing the world. When different groups met, languages blended or replaced each other, and new identities formed. Cities often grew where routes converged, because movement brings trade, ideas, and security in numbers. Over time, these patterns left signatures in genetics, place names, and the spread of technologies like farming and metalwork. Human migration is not one single event. It is a repeating feature of our species, driven by climate shifts, conflict, curiosity, and opportunity. When you look at a modern map, you are also looking at countless older journeys stacked on top of each other, like footprints that never fully fade.
Ancient trade routes often followed animal corridors and seasonal water. If you are traveling without engines, you pay attention to the same constraints as wildlife. You need water, forage, and safe passage. That is why many early routes traced river valleys, mountain passes, and chains of oases, the same kinds of corridors animals use when the wider landscape is harsh. In parts of North America, trails used by bison and other large grazers helped reveal practical paths across plains and through breaks in terrain. In arid regions, caravan routes linked wells and seasonal rivers, and travelers learned to time departures to avoid the worst heat and to reach the next water before it vanished. Movement shaped commerce, and commerce reinforced the routes because repeated travel turned faint paths into reliable roads. This overlap is not accidental. Geography offers only so many workable options. In a way, human trade learned the old lesson of migration. Follow the corridors that the land makes possible. Migration can be a survival bet, trading danger now for safety later. Staying put can be comfortable until it becomes deadly. Moving can be dangerous until it becomes the best option. Many migrants are not fleeing for drama. They are making a seasonal trade. Risky storms, predators, and exhaustion are accepted now because the destination offers a higher chance of surviving the months ahead. Some species even split the bet. Part of the population migrates while others remain resident, as if the species is diversifying its strategy. In years with mild weather, the stayers may do well. In harsh years, the movers may be the ones that survive. This makes migration feel less like a simple instinct and more like a long-running gamble shaped by evolution. The world is never perfectly predictable, so the best strategy can be one that spreads risk across space. Migration is a way of not putting every life in one basket of weather, food, and danger. For many species, a successful year depends on one perfect arrival window. Sometimes the entire year balances on a narrow moment. A bird might need to arrive when insects are peaking, because those insects will feed chicks that grow fast in a short season. A grazing animal might need to reach fresh pasture just after rains, when plants are most nutritious and before they dry and toughen. If arrival is late, the best food is gone. If arrival is early, the food has not appeared yet, and precious energy is wasted waiting. This is why timing can matter as much as distance. Migration is not only about where to go, it is about when to be there.
That tight window can be set by temperature, rainfall, ocean currents, or snowmelt, and it can shift from year to year. The traveler is trying to meet a moving appointment, and the cost of missing it can echo through survival, growth, and reproduction. The same route can be safe one year and deadly the next. Migration corridors are not fixed highways with consistent conditions. A route that offered calm winds last season can become a gauntlet when storms line up differently. A river crossing that was shallow can become a flood, and an ice bridge that held firm can fracture earlier than expected. Wildfires can remove shelter and food from a stopover region, turning a familiar resting place into an exposed stretch with nothing to eat. Human changes can arrive suddenly too, like new construction, new lights, or new barriers that make an old passage more hazardous overnight. This unpredictability is part of what makes migration so dramatic. The traveler is not following a perfectly reliable script. It is adapting to a world that can change while it is in motion. Success depends on flexibility, endurance, and sometimes plain luck. When we watch migration, we often see the winners. The route itself can explain why so many attempts never finish. Scientists map migrations with tags, satellites, and tiny backpack transmitters. For a long time, migration was a mystery, pieced together from sightings and guesswork. Then, researchers began marking animals, first with simple bands, and later with devices that could record location over time. Today, some birds carry tiny transmitters that send signals to satellites or to ground receivers, revealing where they stop, how fast they travel, and which routes they prefer. Marine animals can be tagged too, allowing scientists to see paths through open ocean that once looked empty on the map. These tools have transformed migration from a seasonal story into a set of measurable journeys complete with detours, pauses, and surprising connections between habitats. Ethical design matters because the device must be light and safe for the animal, and researchers work hard to minimize impact. The payoff is knowledge that can guide protection. A map of movement can reveal which places matter most and which threats intersect the route. New tools can reveal hidden routes, including deep dives and night flights. Technology is beginning to show what human eyes cannot. Radar can detect waves of birds moving at night, even when the sky looks empty. Thermal cameras can reveal bats and birds passing in darkness, turning invisible travel into visible flow. In the ocean, tags that record depth and temperature can uncover dive patterns that explain how animals use the water column during migration. Scientists can also use sound to track movement, listening for whales and other marine species as they pass through corridors. Even genetics and environmental DNA can hint at where animals have been because traces of life linger in water and soil for a short time. These tools do not replace field observation, they expand it. They let us see migration as it actually happens in conditions where humans rarely witness it. Each new method is like switching on a light in a room we did not realize was full. The result is not just better maps, it is better understanding of how movement depends on timing, habitat, and hidden pathways. Protecting migration means protecting many places, not just one habitat. A migrant's life is stitched together from a chain of locations, and the chain is only as strong as its weakest link. Breeding grounds matter, but so do the stopovers where energy is rebuilt and the wintering areas where survival through the harsh season is possible. For some species, even a single safe crossing point can be essential, because geography funnels movement into narrow corridors. This is why conservation for migrants often requires cooperation across regions and countries. A bird can nest in one nation, refuel in another, and spend winter in a third. If any one of those places becomes unsafe, the whole journey can fail. Protecting migration also means protecting timing, because water levels, food booms, and safe darkness can be as important as land itself. When we protect a network instead of a single site, we protect the logic of migration. We keep the route workable, and we keep the world connected by living movement. In a moving world, migration is one of nature's strongest solutions. Life does not always try to endure in place. Often, it endures by moving. Migration allows animals to escape seasons that would starve them, to reach nurseries that give young a better chance, and to follow resources that appear and vanish like traveling waves. It spreads life across landscapes and oceans, linking distant ecosystems through repeated motion. It also builds resilience. When conditions change in one region, a migrant can sometimes shift route, shift timing, or find new stopovers, because movement creates options. That does not mean migration is easy. It is costly, dangerous, and exquisitely dependent on the world staying connected. Yet, the strategy is powerful enough that it is evolved again and again across very different kinds of creatures. Watching migration is like watching nature solve a problem in real time. The problem is survival in a changing environment. The solution is travel guided by senses and timing that can feel almost miraculous. Movement becomes a form of wisdom. As we come to the end of our journey, you might notice how wide the world feels when you think in routes instead of borders. We wandered with travelers of every scale. We followed whales along coastlines, birds across night skies, and tiny drifters through the ocean's layered roads. We listened for the cues they trust: a magnetic pole, a shifting wind, a tide that opens a doorway, a bloom of food that slides across water like a moving promise. We even traced the quiet ways migration reshapes places. When bodies carry nutrients inland, when stopovers become lifelines, and when time turns into a kind of invisible clock. And now you can let all of that motion settle. Imagine those great paths softening into stillness, like footprints fading in sand after the tide returns. Let the thought of distant journeys become something your mind can simply watch without following. You do not have to solve anything. You do not have to go anywhere. Let your shoulders drop. Let your jaw unclench. Let your breathing find a pace that feels unhurried and easy. If you enjoyed this sleepy science wandering, you can like, subscribe, or share a thought in the comments. It helps this little corner of calm reach more curious minds. And if you happen to still be awake, there will be another video waiting for you on the screen, ready to carry you onward into a new topic at the same slow and soothing pace. For now, allow the day to loosen its grip. Let your thoughts drift like travelers finally reaching safe ground. And when you are ready, let sleep arrive in its own time. Sleep well, and good night.